Hey, wanted to show you the abomination I came up with in the last couple of days. What's it about? In libgdx there's a lot of native code. We wrap a lot of awesome third-party libraries like Box2D, SoundTouch, MPEG-123, Civ, Morbis, and so on and so forth. I write those bindings manually for the reason that tools like JNA, Swig, or Java CPP usually work awesomely, perfectly well, but create pretty ugly APIs. That is, they go from C++, C to Java and create things that actually make you work with pointers directly. Even if they are abstracted pretty well, it's still a little cumbersome using them. So for that reason I write the bindings manually, like the Box2D binding is written entirely from scratch without any help of any automated tool, which is error-prone and masochistic, but it allows for nicer APIs. So what I wrote is a little helper tool that allows me to increase my productivity when writing manual bindings, and that tool is standalone. That means you can use it for your own projects as well. What does it do? You have a Java file and you can annotate it with C++ code. That's basically it. From there it can generate your .h and C++ files, generate build scripts using AND and GCC, maybe GCC cross compiles if you want to compile for multiple platforms, and finally help you load the shared library and execute your stuff in Java. So what I want to do is quickly show you how it works. Let's create a new project. Let's call it gdx-jnigen test, and let me pause real quick because I need to roll. And I'm back with a freshly rolled cigarette. So I created a new Java project. The first thing I need is the gdx-jnigen as a dependency, so I create a new folder called libs because we like libs. I downloaded the gdx-jnigen jar from our build server. You can get it in this directory here, blah blah. It's independent. It uses the awesome Java parser, third-party library, which is a JavaC based Java parser. Goodie. So let's put it in here, add the dependency. Lots of clicks because clicking is fun. You're ready? So what I want to do is create a class that basically adds one float to a float array. This should be faster in native code, might not be, depends on a lot of factors. Let's just call it adder. Okay, so this is our awesome class. We want to add a native method, so we call it public native. It doesn't return anything. Let's call it add. We put in a float array. We put in the offset within the float array and the number of elements within a float array that should be modified by the following value. Yeah, that's pretty nasty. Anyways, what it should do is add this value to all the elements in this array, starting at offset, continuing with num elements. Goodie, so let's write a main method. The first thing we have to do is generate the native code for this. And as you can see, there's no native code there yet. So let's add the native code. For int y equals offset y smaller than num elements, values, oopsie, values I plus value. So that should do it. That adds this value to all elements starting at offset, and we do it to num elements. gdx-jnigen will automatically generate code in JNI to get this as a pointer, so you can access it like this. We will do a couple of other things that you can read up in the documentation of native code generator, which we're going to use now. So we need a new native code generator that has a generate method which takes the source directory. This is the directory where your Java files are. Class path. This is the directory where your .class files are. And the output directory. This is the directory where the .h and .cpp files will be put. So we read all the files in source. That's pretty nasty. Why did I do this? Let's put it in a directory. Move. Yes. Logic. gdx-jnigen test. Okie dokie. Great. So the output of this will be a new GNI directory in here. that contains a .h and .cpp file for this class. If I had more classes, they would be automatically picked up and code would be generated for those as well. The declaration of the native code works like this. You have a block command, and the opening tag has to be on the same line as your method signature, your native code method signature. So let's execute this. Oopsie, wrong button. Let's execute this. It's found the adder.java file as a native method and generated C code accordingly. Put it in the gnigen folder. So there we go. Here's our fancy code. Here's some additional setup code. Everything is nice and dandy. Hooray! This is the first step. The second step is generating build scripts for the targets. That means for the operating systems you want to target. Let's do this. gdx-jnigen has a couple of classes that help you. Build target class that basically specifies which compiler to use, which flags, what files to include, and so on and so forth. We can use a factory method here. We want to target Windows 32-bit, so this is false. Ugly fugly. As you can see, target has a couple of things you can set. Read up on them in the documentation. I need to do the following. I have to set the compiler prefix, which is nothing on my system, because I don't use Linux here for the recording, but Windows. But that's about it. The next thing I need is a build configuration, which is global. This specifies things like shared library name, like this, and we call it adder. So this means we will have libadder.so, adder.dll, and libadder.dylib on the respective targets. We only have Windows, so we only get the DLL. So once I have that, I can create a new AND script generator and generate my AND scripts. I put in the config and one or more targets. I only have one, so I put that in. Kaboosh. So I still generate the adder file. It wouldn't do this if this file didn't change. Let me show you that again. So it checked that we are already up to date, so we don't have to generate anything. Then it wrote a build script for the Windows target and a master build script. And those are put into your gdx folder, along with gdx headers for various reasons. Let's just say it works. So this one will execute all the build scripts for all the targets, in this case only Windows 32. And once it does that, it ends up giving you the shared libraries in the libs directory for the specific platform, as well as a vat jar that contains all of those shared libraries, so we can load them from within a jar file, as is the case with a lot of things in libgdx, like gdx natives, gdx backend joggle natives, and so on and so forth. So let's execute the builds. This assumes that you have the compiler on your path and AND on your path. I have this, which is a glorified version of process, and I just execute the AND file. gni build.xml. I want everything to be verbose, which are the parameter. This is the parameter to AND. And let's run this. Hooray, hooray. Link successful. So what we have now is the adder natives jar, which contains all the shared libraries for all our targets, in this case only Windows, as well as a separate directory where you have the plain shared library. Great. So before we can execute this method, we have to make sure that we actually load it, and you can do this in two ways. You can either have the natives jar as a dependency on your project, or you can load it directly from a jar file, treating us as a zip file. For testing purposes, I use the later method, that is, I specify jar file instead of having it on my class path. For production, you want to have the jar file on your class path, so just add it to your project as a dependency. We go the other way because it allows us to test stuff really quickly without having to refresh in the fucking package explorer all the time. So we have to load the shared library from the natives file, natives jar. So we have a new gdx-jnigen natives loader. Oopsie, shared library loader. Yes. We specify the location of the adder natives jar file, which contains the shared library, and then we tell it to load that shared library for us, which is called adder. Let's see if that works. It probably explodes, and here's why. yes, it explodes with a null pointer exception because I didn't care to add nice errors. I run a 64-bit VM by default. We compiled for 32-bit, so I have to change that in my run configuration. Run. Yes, and everything went fine. And we also loaded the shred library, this one, which is in here. So, finally, we can execute our stuff. It takes a float array, an offset and the number of elements to modify as well as values, so let's create a float array. Values 1, 2, 3, 4, 5, and new adder, add values 0. We have 5 elements in there, and we want to add the value 2. And we want to output it. Yeah. Okay, so generate the native code, but only if it changed. We generate build target scripts and the master script. We execute the build so we have an up-to-date shared library as well as the native char. We load the shared library and then we can execute our actual code. So let's do this. Hooray, hooray, it worked. You can now go in here and modify stuff, like you can say printf, oh no, a syntax error, and execute everything again. And the build executor will actually parse the output and show you where the errors are. It says there's an error, expect a semicolon before original, blah blah blah. I modified it so you can actually jump straight into your Java file and get the error highlighted in there, which is pretty convenient. So I just remove this and everything's fine again, re-execute it. File link, done. This piece of code I usually put in a class called xxxbuild, so I can execute it every time I change something. Sorry, this piece of code. And this piece of code I put into my tests just so I can quickly iterate and reload the natives really fast. I could now go ahead and just add new methods like native void subtract. We basically do the exact same thing, but instead of adding, we use subtraction. So let's put it here. I could reuse the adder. So let's do this. Stupid. My shortcuts fail me. It's of course idiotic to have a class that's called adder, but that's a topic for a different time. So I add the value 2 and then I subtract the value 2 again. Kaboosh, kaboosh, kaboosh. That didn't work. My fingers fail me. So yeah, so everything is fine. Let me just quickly pause and see how much time I spent already. Okay, I have 2 more minutes. So in your production code you would actually only want to load the library and then do whatever the fuck you want. I put this in a build Java file usually. I show you an example. The audio build file is in the GDX audio extension. It's responsible for building the native code for MPEG-123, Vorbis, KISS FFT, SoundTouch and so on and so forth. Here you see a more elaborate use case for gdx-jnigen, but that's pretty much my build script for the entire project, so there's nothing else I have to touch. Same is true for other extensions like Bullet, STP TrueType, which is I think a little easier. Yeah. So that's all I need to build STP TrueType for all my platforms and actually have it working. And the more elaborate examples in terms of the C code look like this. You can have GNI sections that specify things like includes and classes and structs and so on and so forth. And here's how it looks for this binding. I would say just browse the Java docs of native code generator and script generator and the other things in gdx-jnigen. Browse the code of the extensions and box2d and all the stuff to get a feel for how things work. Okay, enjoy.